there are the chances that he forgot to make some entries. Similarly, if we go with the electronic sensors based inference, then most of our here from the electrical background, we understand the inference. So what happens is like sometimes suppose like the communication cables, they are very thin, and suppose some power cable is going nearby that, it can infer some signals. So your values may be multiplied by some values. You can still get some garbage values. Or there may be chances that the power source has failed for that sensor and sensor wasn't recording anything. So these all are the practical life challenges which you will be getting while developing your problem statement and like going through your data. So this is what we call as a data cleaning. So in data cleaning, generally we use to fix the data part. Okay. We try clean data. We try imputing the data. We try removing the data. So all these things depends on the project, what we want to do. Okay. Then after once we have the proper data available, what we do is we call it as the clean data or the base data. Okay. And we store this data in some of the form. If it is done structured form, we'll create a new table in the database and we'll store it like that. If you want, like if you don't deal with some such databases, you can just create a pickle file out of it and you can store it even in your hard drive. So the next time you no need to start the process from second and third. Now you have the ready data available. You can go through with the step number 4. Okay. Now step number 4, which is the most critical thing, which we call as a data exploration. Your 80% accuracy of your machine learning model purely depend on your fourth part, which is the data exploration. This can also be known in the market as the EDA, exploratory data analysis. Correct? So in data exploration, what we do is we perform two types of synthesis. Okay. First thing, definitely, as we all are belonging from some domain. So domain gives us some idea. So suppose like if we are just talking about something, then I'm just take an example of power systems. Correct? So generally, it is used to seen that the for any thermal power plant, your voltage on which you are generating the power, that voltage will also be constant, and then the power will also be constant. Or like in case the frequency is constant, correct? But in the change in frequency, your change in voltage will be observed if you are keeping your power constant. So you have a relation out of it, correct? Now we cannot go blindly always. Okay, it's okay that even we have learned it from the like last 12 years, 15 years, or maybe even more than that. But don't go blindly on any of the learning what you have learned, because theoretical knowledge is always different from what actually happens in the practical. I'm not complaining, but this happens many times. So we call these all statements which are coming from the domain as a rule. We call it as a hypothesis. Okay, and we'll test it. So first important thing is when we say that there is some relation between power, voltage, and frequency, we have the data, okay, and let's try plotting it. Let's see that is it really true in all scenarios. If we found it true, then we can say that yes, this is actually validated, and from now onwards we can use it as a thumb rule. If it is not validated, then let's try to find it out like where it is applicable and in which particular area it is not applicable. Maybe in certain scenarios, like in some weather changes or like in case of like sudden demand change, these things may not be possible in an actual life. Okay, so this is what first thing is the hypothesis part. Now second thing comes, which is purely up to the data part. Okay, we use our data, we try finding out the correlation between the data. We try seeing that how one data is dependent on the other, how we can remove such some data. Can we create a few more features, which will be the next step, correct? The feature engineering. So sometimes what happens is like we have explored everything and we weren't able to found something new, correct? Because always remember that the data is a purely different thing. It's a different way of looking at the life, looking at the problems, correct? But as we all are connected with the domain, the 90% time we think any problem from the domain side, correct? If the domain would be that much involved in your project, then definitely it can create a hindrance in your part to actually achieve the maximum efficiency of your models. So ideally, both things should be used as a 50-50%, correct? Only use the hypotheses which are well tested through the data. Those things should be adopted from the domain. Otherwise, definitely, sometimes what happens is, so just again giving an example, correct? So nowadays, if you see that the temperatures are changing, correct? Every year we hear that the year on year the temperatures are increasing. This year, like it was more heater than the 122 last year's, correct? So these all types of data we have, but if we just think that okay, year on year, every year this will be increased, then I think it should be increased from last year. But maybe the last year's temperature was not that high as was the previous year. Correct. And it's actually true if you go and look at the data. So sometimes what happens is definitely global warming was one aspect, and when last year everything was like under the COVID situation, uh, the due to this pandemic and the lockdowns, there wasn't that much contribution to the global warming. So even the overall temperature was low. Correct. So maybe these things are not related from that domain, but if you look at the data carefully, you will definitely see some relation between them. That okay, the vehicle movements they were reduced, many industries weren't working, so you still see that yeah, there was a drop in the global temperature. Correct. So these types of stories actually data can tell you in this type of data exploration study. Now coming to the feature engineering is nothing else but sometimes like okay, one more important thing that machine learning concepts we actually break it into the two parts. So one we call is the conventional machine learning, and second one is the like the new age machine learning part where like all these neural networks comes. But in the conventional machine learning, correct, most of the things your all products they are actually divided by one single line. Okay, a single line means like if it's a clustering, you'll divide it between two. If it's a regression, you are again going with the lines. Correct. So ideally, the more you put your data to the linear form, there are the higher chances that you will convert your model with the more higher accuracy. So sometimes we may have some data which we need to find it out, but the data may not be an linear data. So it's possible that you do some feature engineering, maybe the log of that expression, or maybe use the transform functions, correct? Or you convert the ratio functions and try to make that all your variables into the linear segments. Then the conversion rate will be much more higher. Then sixth part come, which we call as the predictive modeling. Once we have the final data available, we have prepared all the features, then we go with the modeling aspect. Now, modeling aspect, again, like it's very easy. We go with like, is it a supervised or unsupervised? We know that if we have the data available, we'll go with the supervised. If we don't have the tags, we don't have any knowledge, we just got some data and we want to do some analysis, then we go with the unsupervised learning. Now, in supervised learning, again, like we have two aspects, like it's a regression type of model or it's like a classification type of model. So based on our problem statement, we choose one of the model. Now, here the point actual problem comes, correct, which consumes most of our time. Now, the point is like, even if you go with the regression or even if you go with the classification, you'll see that there are the several models available in the market. Okay. If I just talk about the classification, most of the people directly go with the, okay, let's go with the decision tree. Let's go with the random forest. Okay. Definitely, you may get some good results. There are chances you may also not get, like, if it's simple, correct? You may not be at the global maximum. Okay. So there are the chances. But how many different models we can try? And also, the next problem is every model has few hyperparameters. So hyperparameter means like if we just talk about the decision tree, then like how many depth we should go, how many nodes we should try, correct? What should be the cross entropy, like that barrier. So all these things are considered as an hyperparameter. So definitely, if we select one model, then also we try fine tuning that hyperparameter so that this particular model can give you the maximum efficiency out of it. But idea is like you will be deep diving either into the decision tree, you may be deep diving either into the random forest or SVM or anything else or KNN. There are several models, correct? So this is the sixth number part which takes the most time of yours, correct? Now, after doing everything, suppose like you have built some final model, the seventh step comes, which is like very easy. Ultimately, you cannot give this model to someone, correct? You will be making a final product, a web app. Mostly 90% cases we make the web application where the model is running in the backend. People are giving the live examples and they are seeing that like, okay, is this model is predicting something or not? Because ultimately everything is going to be an consumer experience or like some behavior for that aspects. Okay. Uh, just a second, team. Okay. So the next, I hope like you guys are able to hear me. Correct? Okay. So the next part is what is the AutoML? Okay, and how it can really help you out. So either you call it AutoML, you call it the automated machine learning, or otherwise you refer by it any means like AutoML, automated ML, or automated machine learning. There's all words like you can Google it up. So ultimate, benefit of it is like it's automating the time consuming, correct? The six number step, which is actually going to take the most of your time in your project, like maybe around 70 to 80% is time is denoted actually into the six number step. So it's purely to that part. Okay. Now, second part is the iterative tasks of machine learning models deployment development. Correct. It's these all tasks were iterative. We may be going with any one of the model out of some several models. Then again, then we are trying the different hyperparameter tuning parts or the aspects out of it to tune it. So all those things comes under this particular part. Now, coming to that, how it will actually benefit on machine learning, like a data scientist or an ML engineer or a professionals like you. So first thing is like it develops actually a highly scalable model. Okay, so you can finally like download the model out of it, and you can actually put it to your production environment for that web apps for the larger scale audience also. Okay. Second thing comes to the efficiency. Definitely, it's going to give you a good efficiency model. The productivity is high because like it's saving the time, and like the professional's time is like more way more important, correct? You would be putting some more times into the other research if you are able to save some time out of it. This model are sustaining models. Sustaining models means like it will not like go to the overfit situation just to give you an higher accuracy, correct? So if you are into the overfit model, definitely you will be performing like very few days, correct? The graph will be sharply down for the efficiency in such cases. And next is the high quality. High quality means like it will be a very clear code, so you no need to dig out about it. You can really see that what hyperparameter is it fixed and how everything was being done there. Okay. Now we'll be seeing a few AutoML frameworks. So you can see that there are so many icons on my screen. So they all are the type of AutoML frameworks. Basically, we are using here the Python language. I hope most of the people are using the Python language framework there. Correct. So yeah. So we have yeah, great. So we'll be discussing a very small points about each and every of these aspects. Okay, that what are the different ML frameworks that are there and like what actually they provide to us. So if we go with the first one is actually the PyCaret part. Okay, and PyCaret it's actually again a Python based low code machine learning library. This is the only one library which is going to solve your problem from the step number 3 to step number 6. Okay, a single library. Ideally, this PyCaret is an alternative low-code library. Why we call it a low-code library? You will again see it like we'll be taking this as one of the example for our practical assignment today. Okay. It's also like exponentially speed up your experimental cycles because it's very powerful than all other frameworks which we are going to discuss. Also, it has the all the frameworks. So, like, if in general you are going with the machine learning models, most people use the scikit-learn libraries, correct? Or otherwise, nowadays people are actually using the XGBoost or the like BGM. It actually install those libraries in the backend. So, ideally, if you are using this PyCaret and PyCaret has developed some KNN model, uh, it's 100% possibility that that model is actually built using this scikit-learn library. So even in future, if you want to just use that model, you can just go to the scikit library, you can install that, and you can start using those models. Okay. But the good part is it's not limited to that level. Okay, there is a complete development team for the PyCaret who are keen involving the new models and the new library which are coming to the market. So you may discover or end up with your model's performance with some of the model which even you may not know that I haven't heard the name about this model. What model is it? Because maybe this model just like added to this library the last month, and this was the best performing model for your project. So there are these types of chances, and that's why these models are actually good because they try each and every different types of models available in the market for your data set and specifically to your problem. The only thing is like you should be very what to say that you should be very conscious while just defining your problem statement, and then even those low line code, then you should be very sure that what should I provide in this low line codes. Next model is H2O. This is the second best library, and I don't know, but in this, in H2O's time series learning, I hope that how many of you use the Kaggle there? People, you would be knowing the Kaggle, correct? At least nobody in chat. Yeah, okay. Finally, one people. Mr. Gautam has accepted that. Yeah, he's using Kaggle. So in Kaggle, you know about the grandmasters, correct? So we have one Indian who has the 410 masters in this, correct? In all the four categories. So even he is involved in one of the time series functionality which is being used by the H2. So this H2 is like that level of library. But again, coming to the part, now H2 only solves your step number 5 and 6. So 5 and 6 means the feature engineering part and then the machine learning part. You will have to dig out the data, you will have to explore your data, you will have to reform your data, and then only you can take it to the H2. Now here, like these are the limitations of H2, but definitely it also tries, there are the list of the models which you can see here. So so you can see, okay. So most is like the generalized linear models, your boost models, then your random forest. It also works with the deep neural networks, okay. It also works with the GAN, like generalized inventory models, and then K-means, and all these models, correct? And you would not have even heard about this models thing, correct? But what you see is like these libraries are actually the libraries which take care of any new model coming into the market and adding that. And the good part is actually H2Os can be used on the R and Scala. So Scala, it's a new framework which is coming into the market, like a language which is used mostly when you are using, if you are using the Hadoop or the Spark, you guys would have interpreted with the Scala for the big data part. The R, this language is actually dying, but still few companies are using R. So H2O has an interface for R, Python, Scala, Java, JSON, like for all those things, correct? And the good thing is like it can directly be used on the Hadoop or the Spark system. So Hadoop means like definitely it would be having a clustered system where like more than two PC, maybe up to hundreds or 1,000 PCs are connected in parallel to make it as a supercomputer and use it for the later on. Now, the next model is about the Ludwig. So Ludwig is again a toolbox that permits users to train and train the deep learning model specifically. Okay. So now, if you are going to like just as an example, that CNN model, correct? Instead of that, you can directly use the Ludwig. It will try. So I heard that one person asked a question that what activation function we should use, correct? So these are the general things that many time we got confused. We don't know like which model activation function we should use. Then we try again, like it's again an hyperparameter, correct? So you'll be trying various different things. Now suppose like you have the three layers in CNN, and then like the final layer of the flattening, and then you have the final layer of softmax. But we all know that the final will be either the softmax or the cross entropy. But before that, in those three layers, which activation function we should use? So in this such cases, you can directly use the Ludwig library, and this framework will run and will give you the final optimum model. And ultimately, in all the open source framework which we are reading, you can be able to store that model into the pickle form or otherwise in the binary BSON form. Okay. The next is the ML box. So now this ML box, it's only connected with the Python. It's purely developed for using Python now. Okay. It's more towards that the conventional machine learning libraries and also to the deep learning library with the light BGM. Okay. This may not be supporting to the XGBoost. So now you should be knowing that in which particular problems we are solving, what are the possible scenarios are there, and then you use that library. And if possible, you directly go with the PyCaret and H2 because that will save a lot more times of yours. Now, again, the ML jar. So ML jar, it's purely towards the supervised learning. It doesn't support the unsupervised part. And it's basically to understand the data, like automated exploratory data analysis. So it will solve your problem number three. No, sorry, the problem number four, five, six. Okay. You no need to do the EDA or look algorithmic selection and the hyperparameter tuning. So that's the best part. And third is the automated documentation. This is the best part, correct? So whatever the model has been developed or what parameter it took, what different models tried. So ultimately you will get an .html or the .pdf file, or otherwise like you can convert it using the NV convert. So you'll get even a documentation that what were the models were tried. So this may be even easy for you to develop the final reports in such a like a research part, correct? Now coming to the teapot. So this teapot, it purely looks like this like teapot. That's why we call it as a tea separate in the pot. So this is actually a tree-based pipeline optimizing tool, correct? So the recording. Okay. So this teapot is basically being used mostly towards this random forest and the decision tree. So it will help you to quickly like hyperparameter tuning of those particular parts. So this is purely to the optimization tool of in such categories. Now coming to the next part, this is FLAML. Okay. Now this is again a very lightweighted framework. So very lightweighted framework, then definitely you'll have to uh, negotiate about that. Correct. So this is basically invented by some Microsoft researchers who were using this to for both cost and error. So I don't know like how many of you are actually related with the machine learning history where in initial beginning, correct, the intent was to make a every problem, and then the concept of this cost and error comes to the mind, correct, which is now actually the base for your reinforcement learning. So this cost and error ultimately then you need to make at a thin layer where your cost and the error like both are at the like it's a tie-up kind of thing, correct? That you can handle that much cost and at that much error. So that's how that thin line you achieve in this particular framework. So this is purely for that feature enhancement and based on the cost and error function, finding out your models. Next is the light AutoML. Now this light AutoML, it's like again in uh, the group which basically works on the again very conventional part, which is the classification and the regression on to the supervised learning, not to all other like deep learning framework and all. Now, similarly, like you have the eval ML. Now, this eval ML, it's basically, and you can consider that this actually uh, given an inspiration to a lot of members to create their own frameworks. Okay, so if you see that it works on basic fundamentals, so it gives us the idea about like the automation should be there, then the data check should be there, correct? The end-to-end pipeline should be formed. Okay, so if you see its end-to-end pipeline, then you will see that the feature engineering, feature selection, and the various modeling techniques. It means like it's again solving your point number 5, 6. Okay, it will create features, it will select features out of it because maybe all features what you are pushing to it may not be useful for the model at the end. Correct. And lastly, the domain specific object function. So in that case, like you can create a hyperparameters in their perspective syntax what they provide, and that will check and validate your hyperparameters. So in such a cases, it's actually doing your EDA also, but the one part of it. Okay. Now going to the Auto PyTorch. Now many of you would be using this like the PyTorch framework, right? So this is the same Auto PyTorch for that. It will try all the functions of the PyTorch in an iterative function. Uh, Similarly, you have the Auto sklearn, but it's again like limited to the sklearn functionalities and whatever the models are available within that. So its main work is to recursively using each and every model which are connected with the sklearn framework. Now the next part is about the auto Keras. Similarly, the Keras you would have used. So one more thing which I'll tell you today that Keras is not actually a machine learning backend. Okay, Keras is was basically developed to form a simple language. So if you see that there are the three biggest player at that time, the Microsoft Piano, then this Google's TensorFlow, and then this Meta's PyTorch. Correct. And data scientists were actually jumping from this like Keanu to TensorFlow and TensorFlow to PyTorch, and all these three were having their different syntax. So sometimes making model, then again changing the code, it becomes very pathetic for them, correct? Because ultimately we are not born coders. So what happens is we come up with a new language framework which is called as a Keras. Now, if you see that in Keras, you start writing your model dot sequential, and then you start providing that what will be the sequence of layers you define, correct? But ultimately, that Keras backend can be changed. If you have just TensorFlow installed, then Keras automatically grasps that TensorFlow. Whenever you are running Keras, it's ultimately running the TensorFlow in the backend. So what Keras does is it converts the language code from Keras to TensorFlow library and then learn the TensorFlow. Also, if you have installed PyTorch and Theano, you can just change Keras backend to PyTorch, Keras backend to Theano, and you can run it according to that. Okay, so that's how this Keras works actually. And in similar fashion, like you can use this auto Keras. Similarly, auto Gluon. This is also like a file which mostly like work on the deep learning part, where you can actually use it for the text, images, and the tabular data for whatever the type of uh, data you have. Correct? Even with the big data. So now let's do some practical aspects. Okay. So sorry for this. So I'm basically using Miniconda environment. It's the same as a Python. Okay. So we'll just go with the Jupyter Notebook. Uh, I hope is my audio is okay to you all. Yeah. Okay. Great. So share the PPT if possible. Okay. I'll put this PPT and this Jupyter Notebook on the GitHub, and we'll provide this link to Chandrasekhar sir. You guys can collect it from there. Okay. By meantime, this loads. I'm sorry, like this PC is a bit slow. If you have some query or question, please you can ask the questions, or if you have something else to discuss, we can discuss about that.
Any questions? I'm audible, Kapil?
Yeah, yeah.
Okay,
Clear.
okay. Thank you. Thank you.
No questions. No. Okay. So while I'm doing this, I'll show you this thing also. So I'm just creating a new environment into the Python using the conda. So it's very simple. Like you can do it like conda create hyphen n denotes to the name. I'm putting this name is the J workshop one, and I'm using the Python as a Python 3.8. The moment you hit, it will ask you to install all these functional and basic libraries of your Python. Once it's done, you can just use this conda activate one. Okay, and now you'll see that thing has been changed at the end. Now it shows the GWS one. Now what you need to do is you just need to install the pip install uh, PyCaret. Okay. So if you have got a chance to see that it's actually installing the scikit-learn libraries, analytical library, okay, for the chart, it's actually will be using the plotlib. So this is what the basic libraries which it is using for the backend. Okay. So we'll just wait while we install this PyCaret. You may have to wait, like it's a first time installation, so this may take a bit of time. Okay, so now we'll install the notebook so that we can work in that. Some error, just a second. Okay, great. I hope we should get our link. Great. So we are into the notebook session. I hope that you were able to see this screen, correct? The notebook one? Okay, all done. So that error which came, that was for I just created this new environment, but I forgot to install this library which we call as NB extensions. And that NB extensions is actually gives you this special function. So if you come here, you can actually use this auto save time, code pretty, so it will make your code prettier. So there are like several functions, and we'll discuss even about this in our next session. So we are just taking one example for the PyCaret. Okay, so it's very simple that pip install PyCaret you need to do to install the this PyCaret framework. I even put this code line into the chat box. So I'm just running the libraries. You see that I haven't installed the like I haven't imported the PyCaret right now. But what we are doing is we have a pickle form data. So we are reading the data now. If you see the data, this is an open data available for the diabetes classification problem. Okay. So now, if you see, there are the so many things that the number of times pregnant, then the plasma glucose concentration, the types of sleep, but most of the data is actually in the form of your what call it numerical data. There are no categorical data, but actually it has the ability to handle the categorical data also. But I'll tell you what are the basic simple steps you actually need to perform. So you have read your data. Okay, now you have the data frame. So this data should be available into the data frame framework. Now as we are going to perform the classification problem, we will say that from PyCaret dot classification import all. If you are performing regression, then go for from PyCaret dot regression import all. Okay, so we have run that. Now what we are going to do is in PyCaret it is very easy. You first need to set up the data. Okay, in setup data it will perform various different aspects, and I'll tell you about that. Like what are the basic things are happening behind that part. But when you say that set up the data, then definitely you need to provide it like what is your target variable. We call it as a Y, correct? The X train, Y train. So you see everything happening automatically. So here, if you see, this is what is the class variable. Okay, that class variable means like one, yeah, it has diabetes. Zero means it's not having a diabetes class. So this class variable column name is my target column. So if you see here, we wrote S. It's just like a new set of data we are going to get out of it. So we say that setup. So this setup actually comes from the PyCaret classification library. Now again, remember that if in one function or like in a long file you are using some sequential model. So many times we need to use some first regression model, and then we are in loop we are training a classification function. Then just don't say that PyCaret classification import star and PyCaret regression import star, because this setup is available in both the libraries. Okay, so this can actually create a conflict. At that time, you just say that from PyCaret, and then use the PyCaret classification setup or PyCaret regression setup. Okay, so just take care of this basic Python things. So now what we are going to do, we say that as is equals to setup data. I run this program. Now if you see, the first thing what it generates it says, look, so it started, it's initiated at this time. It's static, it's processing the data, right? Okay. Even you can see the process bar right. It is currently on hold. Now what is on hold? It has given us one point. It says following data types have been inferred automatically. If they are correct, press enter to continue or type quit otherwise. Okay. Now, if you see the number of times pregnant categorical, definitely this isn't categorical data, but um, like the 6 times or the 4 times or the 8 times number of pregnancy, they are different from the number of child. Correct. You may be having like twins also. Correct. So in that cases, like we always keep these types of scenarios as a categorical because we will going to make several boxes out. Correct. So this is a categorical, rest of them is numerical, and definitely the target variable will always be called as a label target. Why label target? Because like it is actually a class. If you see one or zero, it means not like there may be a multi-class also. 0, 1, 2, 3. So three shouldn't be like it's the three times of one. because 3 is referring to some other function. Correct? It's same like the red, green, and blue. Where red is, you cannot say that red is the 2 times of blue or red is the 3 times of green. They all are the different classes. We denote them using numbers, but ultimately the number has no interrelations between the other number. So that's why we consider it as a data type view. Now, as we see that, yeah, all these things are good. It looks good to me. I put enter in this box and done. Now, we see it says that this is what is the session ID which they are denoting to it. Target type, it's a binary. Look, it has automatically detected like it's going to be a binary classification. Label encoding required? No. What's the original data length? This is missing value? No. Numerical feature 7, categorical feature 1. If you found some no data availability, it will automatically include the data. Okay. Now it has like some feature creation things, then the transform training set, transform test set. So it is automatically converted at the 70-30 split ratio, and it has come up with this train set and the test set. Now you see that what is the meaning of the transform train set and the transform test set. Correct? So transform train set means like your now it's not in the sequence form. What sequence provided? It has shuffled the data. Okay, for more easy intuitive part. Now, if it would be a time series data, it will not write the transform training set. It will be just training set because it's at a split at a particular thin line, and you'll see that before data is training data and after data is test data. You cannot shuffle the time series data. Okay. Now it says that it's a CPU job. You're using the GPU false, but if you want to use GPU, you can provide this all things here, like when you set up the data, correct? Target is this, use GPU is equals to true, then you will be able to use the GPU. Now, again, if you see then the transformation methods, other than this, if you want some specific transformation method, you can provide it. If you want PCA to happen, you can provide it. Okay. So it has prepared the data now. Now, if you see that after this, if I directly go and ask it that, okay, then tell me what are the best models which you have compared out of it. So now it has started running the models. Okay. And now you'll see that it's using all these things with the 10 folds. 10 folds means it's the 10 time it's trying on the each and every model. Now, if you see, it has come up with the models and their accuracy. So it says that the logistic regression was the best model which has come up with the probability, like the accuracy of 0.786. Okay. With AUC, recall definitely it's poor. If you are more concerned onto the recall, then you should go with the light BGM. Okay. But if you are more towards the precision, then the logistic regression is best. If you are more interested into the F1 score, then you should take the ADA boost classifier. Okay. So many times this metrics also depend on like how what type of thing is more important for you, correct? Or sometimes like you have the unbalanced data type set where like definitely your accuracy will be high, but it's more important that how precise your output is and how good it is onto the recall part. Right? Also, it provides that how many time it took in terms of seconds. So if you see, this is I think that the fastest model. No. I think these were the fastest model SVM, QD, and the dummy part. Okay. Now the part is like, okay, we have run this thing. Now best model will always store the first model out of it. Okay. Now we have the logistic regression, but do we know what exit like parameters we passed into this logistic regression? Correct. Because after making it model, we would be using this model somewhere else. So for that, you can just use print best because this best is now stored the model, which is compared model up to this setup data. Okay. So now when you just print it, look, this is what is the model. And this is all parameter it passed. Okay. We use this solver LBFTS, total number of times, total penalties, the number of jobs we didn't give it, correct? The L1 ratio didn't give it, max iteration we give it for the 1000. Okay. So what are the functions exactly you can give? And this is the function you can use directly into the sklearn. Also, if you want, you can just use the save model. Save model. Okay. And that model is best, and how we want to save it as done. So now if you see, I'll go back to the files part. And in files, now you'll see we have the my model.pickle.pickle. Okay. You could have give pickle, otherwise you can directly give it a name, it will use that. So So it has created a pipeline. It says that first, this is what the functionalities it need to make. Then it's use the imputer. Then it will use this feature select. What are the features we need to select? And ultimately, it will run this logistic regression part. So next time, if you are running you are having a new data, you just load this data. It's again a simple. You just need to say load model, and that model is my model.pickle.pickle. Okay. Look, definitely its name convention is very wrong. Okay. You don't need to provide the last pickle in the name. It will take pickle part automatically. Okay. So now, if you see that I use this load model and I gave this the file name, it has loaded that model automatically. Correct. And now you can use this predict using this model also. Okay. So you can use this model to predict further things. So that's how these things works. Now, also we want to evaluate the model. Okay. There are the certain things. So if you see this is the best part, you can just type evaluate underscore model and you are again passing the best means your best stored model is there. Now, what are the different types of the hyperparameters, the prediction errors, AUC, confusion matrix? You guys would be knowing about the confusion matrix. If you click it here, these errors are something related to the font family, which like I haven't installed this Sans RP. If you are using the Google Chrome, you'll not see in Microsoft Edge, they don't use this fonts for by default. So if you see, this is what is your confusion matrix. The confusion matrix is readily available here. If you see the precision and recall, you can definitely see how much good the precision. So average precision was 0.69. Okay. And if you also want to see that the gain chart part, you can definitely see that how quickly that 0 and 1 and like ultimately the gain we were getting. Also, if you want, like you can see that the learning curves, correct? So it's just a processing block. This is how the learning curve, the training score, the cross validation score. So you'll get each and everything in this particular, correct? So anything what you want, correct? You can just select out of it and you can use this. So that's how ultimately you can actually make model and save out of it. Now, if you see, or if you remember, while discussing this PyCaret, we said that this is a very low level coding library, correct? What we did is, if you see, we just set up the data and I asked to compare the models and store the best model in my best library. Now, I just say save model best. In this 3 line of piece of code, it has tried several models and it will bring down like maybe your days of work to just like in a few minutes of work, correct? And now you have ready model. You can send this model onto the email to someone else, like if you want someone else to be using it. So that's how it is actually making your life easier. Now coming back to our presentation, so it has reached to certain that level. Are we really threatening? Like, is my job is secured or not for the future? Because I'm a data scientist. So if you see, I don't know like how many are the fan of the Marvels, but yes, I am being a data scientist. So if you see, yeah, this seems to be the Automl, which is like very powerful compared to this data scientist. But if you see here carefully, this particular chart, so there are the 3 steps in the machine learning. Okay, the first thing is the usually automation applicable. So if you see automated, the model validation, the model selection first thing. Okay, it's automatically selecting model. Yes. It's a feature selection. Yeah, that's great. The hyperparameter training. Yeah, that's great. That's what PyCaret was performing. Now coming to the semi-automation application, which is possible. Model selection, yes. Hyperparameter training again, yes. And model evaluation. But that's two PyCaret is doing. Now coming to the usually automation not applicable. First thing is the formula problem formulation. Correct. The problem formulation PyCaret cannot define. PyCaret just start after handling the data. Now collecting data again. This cannot be done by the PyCaret. Data cleaning, not always, because I'll again come back and I'll show you the chart here. Look, it always asks you that what type of categorical imputer we should use. It has used the constant right now, correct? The numerical imputer, no, otherwise numerical imputer mean. But we may be using mean, we may not be using mean, correct? We may be using the first, we may be using the last, correct? There are the several techniques of the imputation. Also, sorry. Yeah. Also, if you go with the model evaluation, then look, it gives me the best models too, correct? Which is the this logistic regression model. Now, Suppose I'm not that much concerned about the accuracy because my accuracy is just dropping with the 3% from 0.78 to 0.74, correct? But for me, the recall was more important. And the high recall is with the light gauge. But if you go blindly with this Automl, it has given you that you should use the logical regression and you will fall with the recall. So still, there are many things where the actual data scientist will be required. Hence, we say that we all know as per the movie also, we know what is the rest of the theory. We are inevitable. Okay. So yeah, that's it for the day. Thank you all. If you have some queries, then definitely I'm open for any question and answer. And stop sharing. We can go with the question and answer. Hello.